So I hit the wrong key here, so the recording actually got stopped. So I'm gonna go again and create an application project. I'm gonna call this one switch_logic. I'm gonna create also a board support package here. There's our hello world template that we're gonna use. We're just gonna edit this in order to do something with the board later on. And here you can open the MSS file. I think it actually opened up automatically for yourself. You got the target information, your operating system, and here you got also the peripheral drivers. You can click in documentation to see a few examples on what is doing this thing, and you can actually import examples here as well. So something really practical for you to do. Go back to switch logic here, go for source, hello world. This is the piece of code we're gonna edit later on. But right now what I'm gonna do is test our connections between the board and our PC. So go for settings, you should see hit here serial. You got port, country. For Zedboard this is correctly. Go for baud rate, select 115200, hit OK. And right now what we want to do is launch the application. So right click here, run as, and launch on hardware. If everything is connected the way it's supposed to be, you can see the progress here. We're not using the FPGA, so hit OK for this part. If everything is connected as it should in the terminal, we should be seeing this hello world message. So everything is working as it should. So right now we can actually go ahead and edit this code. So just gonna paste the same one that I did for Zedboard. I got some explanation here to do. The platform, you get some libraries here like GPIO, GPIO-PS, parameters, TDU, and platform. We should be adding this because we're gonna use some functions that depend on them. So in here you got your main program here. We're gonna use these struct declarations here as a xcgpio config and xcgpio. You realize that we're actually gonna use one for the PS as well. So you can hold control and click on it. You should be able to see which library contains it. Just go for OK and just gonna peek inside a little bit. Here you got the device ID, the base address, the interrupt if it's present or not, and if this kind of struct is dual or not. Our GPIO it is, but our GPIO PS it's not. So in order to get this to work, we actually have to initialize correctly, and this helps in the first configuration on each of those parts for our processor. Here's what's gonna be using on our code for real. You can see that it highlights down on the bottom when we're using. You get some variables for control. It's like the value that we're reading for the dip switches, the value that we're gonna write to LEDs, and you got status and next status just to see if what we're configuring are actually configuring correctly. So you're gonna go here and gonna do a lookup table here. You're gonna lookup config here, and the result from this particular device ID, I'm gonna trigger this function and make some changes on our GPIO config. So once this is done for both GPIO and GPIO PS, we can tell hey status get the configuration initialize for my GPIO, which has this information hold on GPIO_config, and that's the bird's address. You can hold control here on the function as well and click it, and you see what they need and what they do here in this piece of code. So if your status is success, just print those two messages here just in order for us to see if the initialization is done properly or not. And here we're gonna set data directions here. For the first channel we're gonna set all of them as inputs because they are the dip switches, so we need to write 8 ones in a row. We can do this by just writing 0xff, and here we're gonna right now in channel 2 8 zeros because in here we actually have outputs on the LEDs. from the data direction here, from my GPIO PS, you see channel 7, which is the part that holds the LED. We receive 1, but because most of the channel is an input, and in order to use this LED connected to the PS, we're actually gonna need this to be an input as well. So we're going around the loop here forever. So just hit while and put one condition. The value will be a discrete read of what's in our GPIO channel 1. The LED value would be exactly the same. We actually don't need this line of code, just it's more like to help you to debug if you have something wrong in this function here. And then we're gonna print those values in the UR to help us to debug, so we're gonna see them on the console. We're gonna write back the value to GPIO, so we're gonna do a discrete write right now to GPIO channel 2, which is the switches, the LEDs, and we're gonna write there the LED value. So here we get this variable switch count for 0, and we're doing a task with a mask to see that if a particular switch trigger on, update the value on switch count, and if this value is actually greater than 4, we're gonna light the LED on. If it's not, we're just gonna light it off. So here you should see that he tests the mask for 0x8. That was what we were using on Zedboard because we only have 4 switches, so we're gonna put 0x80 here. So once this is done, we should be seeing that he will be multiplying this value by 2. So it starts at 1, tests the first switch, multiplies by 2, tests the second, multiplies by 2, tests the third, and so on and so forth. And this will be the last value, the last value to be tested. So if the switch is greater than 0, or it's greater than 4, or equals to 4, just light up one LED. If that's not the case, just light the LED off in case he's on. So we should never get this far because this is the end of the infinite loop. And then we return 0 for int main here on the top. So now that you understand what the code is doing, just program your FPGA right now with the bit string that you generate on Vivado. Go for program. This window will pop up, will recordedly will give you some progress. So initializing, does something. Once this is done, you should see that the board has actually light up some LEDs to see, hey, your program has been done. So right now I'm gonna save this with all the changes that I've done, and I'm gonna run the application again. So switch logic here, you're gonna launch it, and if you click terminal 1 here, you should be seeing that it's printing values really fast. So just gonna trigger a couple of the switches and you should see that the value is changing. I'm gonna trigger the last switch right now. This is the value that you got. So right now I'm gonna do a little video demo on how to get seeing the results on the board.